All right, my name is Lauren Spencer with Reagan High School. Today we'll be talking about calculating quantitative data, summary statistics. This will be page 47 of the note spiral. This will be page 47 of the note spiral. And hopefully, being take 3, hopefully I've got this thing right this time. We'll hope that this works out. All right, so hopefully you're looking at the computer screen. Hopefully you're looking at the note spiral. And again, this is page 47. So it says custom BS at the top, but you might want to make a note that this is calculating summary statistics. Calculating summary statistics is the main thing we're going to learn, although we are going to talk about a couple of vocabulary words. Once again, you do need to read the notes. All right, I skimmed through them. You need to read them carefully. So quantitative data, it's data that it's just simply data that can be expressed numerically. Examples of this are height, weight, number of pets, GPA, age, etc. Now, interesting on number of pets. Number of pets is quantitative. Type of pet, fish or bird or dog, etc., is categorical or qualitative. And that there's a big difference there, because with quantitative, order matters. With categorical or qualitative data, order doesn't matter. We could say a fish comes first, then a bird, then a dog, or we can change the order. It doesn't matter. But with quantitative data, order does matter. Think of your grade point average. That drives your class rank, and your class rank is an order, all right? How much you lift, how fast you are, how much money you make, all of those values are quantitative, and order provides a ranking for it. So that's basically the idea behind quantitative data. So with that said, we have a couple different types of quantitative data we're going to look at: discrete versus continuous. In discrete data, we're only looking at whole numbers. For instance, the number of dogs. The number of dogs you have would be discrete, because you're going to have 1, 2, 3, or a number of pets. All right, it'd be really sad to have 2.2 dogs. So there are not fractional numbers when we talk about discrete. Continuous, fractional numbers are permitted. Again, volume, height, weight, your GPA, those type of things are continuous. So basic definitions that you need to make sure you know. Now we're going to go ahead and calculate this using a TI-84. I teach the class using a TI-84. Obviously, you can use an Inspire, but I do not show you how, and I don't take the time to do that. And you can hopefully you check the TI-84 out from the school. If you haven't, call the front office and see what you can do to set that up. My emulator isn't exactly like your TI-84, but it has the same operational functions. It looks a little different, but it's the same thing overall. So stat, press edit for enter. So stat, then edit was highlighted, and we press enter. Let's do that again. I'm going to clear that out. Stat, edit is highlighted, then I press enter. Then I'm going to go ahead and input this list of data: 9, 8, 7, 6, 5, 4, 3, 2, 1, and -10. So I just input it into that list. All right, then I'm going to press stat, arrow over to the word calc. One variable statistic should be highlighted, and I press enter. My list should say L1. If it doesn't, press a second, followed by the number 1. And if you look, there's a little L1 there. All right, arrow down. My frequency should be blank in this case because I don't have a list of frequencies. It's asking if I have a list. I don't, so I don't need to write anything. I want to calculate it, so now I press enter. And I get a whole bunch of numbers, and I want you to make note of these, and we'll talk about them just a little bit. X bar is 3.5, and that is the average. That is the average of those values, the average of all 9, 8, 7, 6, 5, 4, 3, 2, 1, -10 is 3.5. That little symbol in front is a sigma. It's a Greek letter sigma for like frat boys, sigma chi. And what we use in math, that symbol means summation. So if I added up all the x's, I would end up getting 35. Then the next thing is the sum of the x's squared. So if I squared all of the values, then summed them, I'd get 385. S of X is the standard deviation of the sample, and I'll talk about what standard deviation is briefly, and then I'll go into detail in the next video. This is standard deviation of the population. So standard deviation of the sample, standard deviation of the population. N is a number of values, and if I counted them up, I go, oh, I have 10 values. My lowest value or my minimum value happened to be -10. Q1 is quartile 1, and 25% of the data is less than or equal to 2. The median, that's my median, 50% of the data is less than or equal to 4.5. Q3, 75% of the data is less than 7. And then so my max value or my largest value is 9. Now I said I was going to talk to you a little bit about the standard deviation. Just going to say, write this, and you want to make this note. Standard deviation is how far the values are from the average, or how far the values are from the X bar. So there's a calculation, we'll learn about the calculation later, but how far the data is spread away from the 3.5. Okay, so hopefully this video worked this time, and we will talk more about CUS and BS and actually learn how to describe data or quantitative data in the next video.